Okay, building again a little bit. I'll read it over. We got a coefficient of friction, so we know that we have to find the normal force at some point. We're pushing this thing so hard that it's accelerating at 2. The question wants to know how hard are we pushing it. I'm always going to start with a free body diagram. Gravity straight down, normal straight up. We're pushing it, I'll call this way forward. I'm going to call that F applied for a pushing force. Friction straight backward, I'll call that FF. Doesn't say anything about it flying in the air, being in an elevator, so that goes back to the boring case. That means that the normal is the same as gravity. You know that gravity is mg, so that means that the normal is mg. We're going to see that over and over again in grade 11. In the horizontal, though, we've got a tug of war. F net equals ma. We did questions similar to this way back when we started this Google Slides document, but it didn't have a mu. I just told you the force of friction and asked for the F applied. This one we have that extra little step. Similar to we did before, when something's got a tug of war, the forward force, or the bigger force, I guess I should say the bigger one, becomes our positive force. Since friction's in the opposite direction, it's our negative force. That's equal to m times a. I don't know what F applied is. I know that FF is always mu times Fn. That's what the coefficient is used for. That's equal to ma. Because it's a boring case, I know that Fn is the same as mg. That's equal to ma. Now I'm ready to solve it. I'll flip one thing over. If I flip the mu mg to the other side, the question asks for Fa, so now it's a matter of plugging in and cranking out, figuring out this F applied. We could common factor out an m, but we'll probably just calculate it anyway. The mass was 4.5. It's accelerating at 2. To that we add the coefficient, which was 0.2, multiplied by the mass of 4.5, multiplied by g of 9.8. When you calculate all that out, you'll get roughly 18.